All right. So for the afternoon session, we'll start with bolt condition, which is mostly dealing with bolt storage and bolt certification. We talked a whole lot with people that were out on the bridge sites yesterday, and they said that bolt storage is kind of an issue out on most bridge sites. They kind of just leave them out and open, so we'll talk about proper storage. Things to talk about, yeah, storage, certifications, and we'll talk about reusing bolts. So typical problems is improper storage and improper certification. So for proper storage, you are supposed to keep them out of the weather, and you're only supposed to open the containers you plan on using during a given shift. So during an 8-10 hour shift, and then after that shift, return them back to the appropriate bucket, cover them up. They prefer to put it in some sort of container. That T1 truss we've been talking about, that major project, they actually use land sea containers. They put them off to the side, and that worked very well. Usually that's not going to be possible, so we suggest you take a piece of plywood or something and put them over those canisters. The one thing you do not want to do is put a piece of plastic or a tarp over it. What you're doing with that is you're just holding in moisture, and you're going to accelerate that corrosion, and we saw what that does to the bolt's performance. Also, while we're on the subject, keeping any kind of foreign material out of fane surfaces, it takes very, very little material in order to just drop that slip coefficient, and you're just destroying, especially if it's a slip critical condition, which a lot of bridges, a lot of the connections are in bridges. So for this, they made it somewhat of an attempt to keep everything off, but that's sunk down into the mud, I imagine, pretty quickly. For this, before you get it up in the air and you're starting to install it, you're going to take a burlap sack or something like that, get any kind of loose mill scale as well as any dirt off of there, and any kind of rust, corrosion. And we'll talk about overspray later during the painting process. That during that project that we've been talking about, that was a major issue. They didn't properly mask off the fane surfaces, so they had to grind for a month. 10 people grinded for a month to get everything out of there. So it can be very time consuming if you skip over that step. So that's very important, especially for slip critical. This isn't an issue until you kind of hear the backstory. They intended to use all these bolts in a single day. While setting up the crane, it took almost the full day to do that, so they were only able to do maybe a third of the work. So after this, take them out of the bags, put them back into the canisters, and put them back into some sort of protective storage. We know a lot of times they'll just sit out here all night, and so it's easier the next day, but this is going to really accelerate any kind of corrosion. So for this destroyed canisters, that's going to let moisture in there. So what you'll want to do is place these into a new unused canister that you can properly seal. So the ideal bolt storage is kind of went over previously. You want sealed containers that are protected from the weather. In a totally ideal condition, you put them in some sort of building, which some of the major projects will do, but that's not likely on a bridge project, I assume. And then land sea containers work well, depending on the size of the project. Basically, just seal them up and keep them out of the elements as best as possible. It's a lot easier to pry open every single canister and just go to town and just leave them open, but it can be very detrimental. You can have lube drying and water getting in there, accelerating corrosion. You need to check all certifications when they get to the job site. You want to check everything. You want to make sure that all this matches with everything that is on your plans. Both the owner and the contractor should be checking this. We've heard multiple stories of the wrong bolts, the wrong nuts coming to a project. Sometimes it can take 2 to 3 times before you get the proper ones. And if you check these right when they get on the job site instead of the day before they're supposed to be installed, you can still save time and not set back the project too far. So this is the rotational capacity lot that we've been talking about as well. Jerry likes to put animals in his presentations. This is his cat. No.
This is how we all feel after lunch.
Yep, so cats. Reuse of fasteners. We talked about this for a long time yesterday. I think we talked for half an hour about this one issue because we had the guy that does the specifications for Minnesota. So you cannot reuse a bolt that has been already fully tensioned except for A325 black bolts. So you guys also use DTIs. So we talked about the crushing of the DTIs and if you can just remove that DTI and reuse that bolt. And we decided on, with the guy with the specification, they're going to change this. They were going to change it to say that entire bolt has to be replaced. Because that's what we talked about for quite a while. So you cannot reuse a bolt after it's reached full tension if it's galvanized or for any A490 because it's such a high strength and can be more brittle. You cannot reuse. An A325 bolt you can reuse, but you have to get the permission of the engineer of record. We had the old bridge engineer from Wisconsin, and over 7 years he got requests to reuse, but he never accepted it. He always said discard the bolts and just start new. You don't really know what you're working with, and you have to go through multiple tests to ensure that they're viable to be used. So
you're talking
yeah.
fully tensioned.
Fully tensioned. So fasteners have been fully tensioned. If you're just touching up a bolt, if they became loose during the rest of it, that is not. It's if you fully tension it and then for some reason you remove it. And the big thing we talked about a lot yesterday, if the DTI gets fully crushed, then you have to throw away that bolt and get a new one. And that was a lot of back and forth.
So what you're telling me now on a galvanized bolt on 7As, your DTIs have 5 protrusions. And requirements are 3 refusals. So if you've got 3 refusals, if they gotta remove that bolt, they can reuse it. But if they've got 5 refusals, which means they're totally crushed, kinda explain that a little bit better, will ya?
No. No reuse. If you got 3 refusals, that bolt is fully installed, fully tensioned. Because you're allowed 2 insertions into the shank. So that bolt has been tensioned properly, and to get 3 refusals, you're gonna be up about 50 kips, 51 kips to get 3 refusals. That bolt is yielded. That bolt shall not be reused, period. You have to take it out, it's trash.
Now, when you're saying is there like a minimum of, like if you're exceeding the 39 kips, are you saying basically that's considered refusal?
Basically, if you go beyond, you snug your connection. Then you go back in and you you go in and you do the tensioning of that connection. If you've done that step of tensioning that connection beyond snug, if you take any of those bolts out and they're galvanized, they're trash. They get discarded. Upon completion of the application of the required nut rotation for pre-tensioning, it is not permitted to turn the nut in the loosening direction except for the purpose of complete removal of the individual fastener assembly. Such fastener assembly shall not be reused except as permitted in section 2.3.3. That says black bolts can be reused with the permission of the engineer of record. Those are the only ones that can be reused. So if you go beyond snugging, and if you go through the stage of tensioning on a connection and you get some DTIs that maybe aren't quite right, you take those bolts out. That's the tensioning process. And if there's an error in that tensioning process, you've got to just discard those bolts and start over. No questions asked.
So beyond snug tight.
Beyond snug tight.
For galvanized bolt.
For galvanized. And the engineer of record in the state is who?
The designer.
Chief engineer of bridge design. I'm not a designer in the bridge office, it's the chief bridge engineer in the state should be setting that policy. And I'm gonna get Ryan in trouble, big trouble. Because he's talking about Finn Hubbard, the old bridge engineer at the state of Wisconsin.
It's not young, is it?
He says Finn isn't young. Finn's young as compared to me. But he's the former state bridge engineer.
Sorry, the former.
I like Ryan's description of Finn, the old bridge engineer.
Yeah, the former bridge engineer. Don't tell him.
But anyway, Finn said that he has never approved it, and they shouldn't be approved. And we ran into that at this auditorium that we had pictures of. You're going to see some more of it. There were things that the chief engineer for the design firm said you don't do. And they've got the control of that. And in the state, it's the state's chief bridge engineer. Okay.
Yep, and just to reiterate, So that is with fully tensioned and removed. If you're just touching up or retightening bolts that have became loose during the tightening process, that is different. It's if you have to remove it after the fully tensioned.
If you turn them in reverse, start turning them in reverse during that tensioning process. Once you've gone into the tensioning process, if you turn them in reverse, they gotta go all the way out and start over, the new bolt.
If it is approved that you can reuse black A325 bolts, you have to be able to run the nut all the way to the shank, not to where it was on that assembly, all the way to the shank, and you have to redo the row cap test. So if you have 5 bolts, the row cap test is going to destroy 2. So you would take a large amount of bolts to make it even reality to even do this. There's some pretty strict guidelines in order to reuse bolts. So there's a lot into it. What is considered proper storage of bolts? Basically keep them dry, keep them out of the water as much as possible from any rain. Who receives and reviews the fastener certifications upon delivery? The owner and the contractor should both be involved in that process to make sure everything's up to snuff. And what should be checked on the certifications? Everything. This, not the cat, this. Everything matches up with your plans. Can the project personnel permit reuse of fastener assemblies? No. Engineer record? How would a bolt be checked prior to reuse? And that is this. The nut has to run the entire length to the shank, and you have to redo the row cap test. So those are the requirements. This is that truss Jerry had in the previous ones. So these are the 36 by 920 top and bottom cords. I believe, is there 18 radial trusses? Something like that? 16? Yep, it's pretty large.
Trusses are 280 feet long, and that auditorium seats 11,400 people at ground level. There's a balcony that'll go in the back in the future that'll seat another 2 to 3. That's not in there, but this was assembled at ground level and then jacked 56 feet with strand jacks. 9 million pound roof system.
And when it comes to the paint, every one of these connections, top and bottom, is slip critical, and that's what they painted over. So one of my first jobs with the company was going around with the clipboard and checking out a couple hundred connections and letting them know which ones they had to grind back and completely disassemble and grind. It was fun.
The other interesting one on
Everybody loved me. It was a really, really good first project.
over 5,000 feet of catwalk. So you get lost running around it.
Yep. Bolted joints. Yep, it's all you. I'm not used to this thing.
Here you go. I got it. Bolted joints. Well, I want to look at common bolting issues, types of joints and how each perform, the FING surface classifications, joint snugging procedures, various sizes of bolt holes, washer applications, that type of thing. Assembly and use, the improper snugging of joints, improper tightening of the fasteners, tension measuring devices not being calibrated. The skid mower here has to be calibrated annually. Torque wrench should be calibrated annually. So you have calibrated tools that you're using. Specification issues, we sometimes end up with poor fastener specifications, poor issues. We end up with poorly written standards or not understandable standards, inadequate. We need adequate knowledge of the fasteners, our specifications, and we need to interpret the specification standards and plans. One of the problems without training is that we end up with, and we like to get everybody involved, and My preference on training is that when we train state personnel, we train consultants that work on inspection or in design for the state, and we also train contractors all at the same time. And I had a situation in Wisconsin back in the early, probably in the 90s. And we had two engineers from a construction company in Wisconsin sitting in on a training course in Madison. And we were talking about an issue in the class like this. And the contractor's engineer said, you know, he said, in a couple of districts, we do what Jerry's saying should be done. In other districts, we have inspectors that won't let us do that. They want something different. And it happened that the construction engineer was in this, the state construction engineer was in the training class. This was in Madison. And he said, Jerry, just a minute. He said, told the construction engineer, we'll take care of that after the training's complete. But we need to be consistent. The state construction engineer said, we need to be consistent across all of our districts. We need to do it the same all over. We shouldn't be doing one thing in one district and something in another. And that's why it's good, in my opinion, you get the contractors in there, you get some of the management from the state DOT in there, as well as all of you that work in the field and whatever else, other positions. And it's good to have maintenance people, the whole cross-section of people in there, so that everybody gets the same picture. And then we end up sometimes on jobs, we end up in a situation like this. Is there anything wrong here? What?
Looks a little tough there.
See anything out of ordinary here that shouldn't be there? What? No, the flanges aren't bent.
The spacers still underneath there.
The filler plate. This filler plate right here is under the flange instead of on top of the flange. This flange is thinner than this flange. This filler plate right here should be up here, above the flange. This bridge was widened with a line of girders on either side. It's a river crossing. There's two splices on either side of the bridge. All four of them were built like this. Our former state bridge engineer sent me this picture. He was no longer at the state when I got it, I think, but anyway, he was working there when this happened. But this should never have happened. My first question was, who ticked who off? Or who wasn't doing his job? Because here you got us, they assembled this, they erected the steel, put this filler plate in the wrong place, bolted it all up, tensioned all the bolts, placed the deck, painted the steel. You know who found this, right? 3 months after the bridge was open to traffic, who found it? Bridge maintenance inspectors. This probably would have served the bridge for the life of the bridge, except you got these gaps in here where you could get rust forming in there eventually, pack rust maybe, but this should never have happened. Now the interesting part of the rest of the story, if you want to hear it. I put it in my my PowerPoint presentation for bolt training. So this happened to be in the Wausau district in Wisconsin, over a river crossing. And so I'm doing this class and I flip this slide up, and the guy in the back of the class says, Jerry, how'd you know I was going to be in your class? It was a project manager for the contractor that built this job. He should have kept his mouth shut. But it's, you know, how did it get by you guys, the inspectors on the job? I mean, you don't accept stuff like that. And 4 of them, I mean, just blew me away. But stuff like that does happen.
So you want to look for any gaps plates? Is that
Well,
what-
there shouldn't be any gaps.
But I mean, if there's a gap between the plates, it's automatically something you wanna look at.
Well, yeah, and here this bottom splice plate should be flat. It shouldn't be bent and warped around a filler plate. The bottom flanges on this, there's a taper on this girder, or on this flange over here. That's why it looks kind of funny, but it's tapered down to the width of the narrower flange. This flange on this end flange here is narrow. This one's narrower than this one, so there's a little bit of a taper here, but this is thicker than this one. And this bottom splice plate should be flat. The filler plate should be on the top just like it is on the other side of the web. And everything should be closed up tight. You shouldn't be having gaps and bent splice plates under there. That's just totally unacceptable, or not. It wasn't designed this way.
Did they just do this one, or the
Huh?
other ones are like this too? Or
What?
did the other one are like this?
All
too?
4 splices were identical.
Really?
I think I've had a tough time getting the bolts in.
Yeah.
Yeah, I would, you know, stuff like that. How did they bolt it up and pull that stuff in there? How did they warp it all into place?
Does they have to change it?
They decided we're not leaving it that way. We're going to take it out. They took the bolts. They moved the traffic to the far side of the bridge. They didn't jack the bridge up or anything. There was enough strength in that connection. But what they did is they took the bolts out on this side, across that connection, pulled that filler plate out, put it on top where it belonged, and put new bolts in and rebolted it, and pulled that plate up as tight as they could. And it ended up with, there's a little bit of warpage in that plate still. There were a few gaps in it. I said, did you epoxy inject the gaps? And they didn't. They probably should have, in my opinion. But they didn't. But anyway, they felt better just because it looked better once it was put together right. But I mean, that kind of stuff shouldn't happen on a job. And we had a discussion yesterday about this bridge in town with a ramp going off of it, where they got all this nightmare of trying to pull the steel together and put it in place. And we had a long discussion yesterday afternoon at the end of the day. And they talked about this ramp going off the bridge, and then when they tied that steel from the ramp into the rest of the steel, they had trouble getting cross frames in. And then somebody said, well, the pier cap was low on the ramp structure apparently, and that affected how the steel tied in together. Well, how'd that ramp pier cap get left low when it should have been up several inches higher? Well, you know, there's this thing about things just happen. Well, they shouldn't happen. That should have been caught. That should have been corrected prior to erecting the steel. And they're having a nightmare getting the steel to fit. And it got into this situation where you want to bolt all the steel up before you tension any of your bolts. And we'll talk about that a little bit more later, but when you install the bolts and you stuff them in the holes, they should be tensioned within at the most within a week. They shouldn't be sitting there for 3 or 4 months snug tight. We'll talk about that a little more this afternoon. Types of bolted joints. If you have any questions, think about them and ask me when we get to them. You got slip critical, shear bearing, direct tension. Slip critical, well, let's just go on with the slides here. Bolted joint types, and the friction in the joint or in the connection when you're tensioning bolts. 70% of the friction's between the nut and the washer. 30%'s in the threads. I had that bolt up here this morning, nut up here this morning. I'm going to pass this one around. I talked about relubricating or having lubricated nuts. This has got Teflon on the back side, or on the one side, and lubricant in the threads. So I put this against the washer and turn it. This works good. I got to turn the light on so you guys can see me. You want the lubricant on the base of the nut against the washer to reduce that friction. Now the problem comes in when you've got plain bolts, you've got oil on the bolts from quenching the quenching oil that's on the bolts from the manufacturing process. That's the oil on the black bolts. So the whole assembly is oily. On a galvanized assembly, only thing that's lubricated is the nut. So you've got lubricant under the washer face, and you've got lubricant on the threads. But if we've got a connection that's like this, in a skew, and you got bolts going through here or here, can you get a bolt in that's in this connection? Here's the connection plate, let's say on a diaphragm or something, or a situation, whatever you got. Can you get a bolt stuck in here that's 3 inches long back in here in the point of the connection? No, you can't. So you've got to go in this way or in this way to that bolt. Here's the nut and the bolt's out here. And you turn the head of the bolt. Now when you do that, looking at the friction and what it takes to drive that nut or drive that fastener. Okay, I'm turning it this way. I'm going up to 50 kips, roughly where you get your turn of the nut tighter. You compress your DTI. That's around 50, 51 kips to compress the DTI. If I'm doing this and the DTI is over here, it takes about 350, 400 foot-pounds of torque. Let's say 400 foot-pounds of torque to get this. Now, 30% of the friction's in the thread, 70%'s in here. So now we've got to turn the bolt head because we can't turn the nut. So where's the friction? Between the bolt head and a dry washer. So instead of this being 70% and this 30%, this is probably 5% and this is probably 95% of the friction here. And instead of 400 foot-pounds, 500 foot-pounds of torque turning the nut, now you're talking 600 or 700 foot-pounds to tighten this bolt, to crush the DTI. Because you don't have any lubricant in here where the two pieces are sliding. We had a job on the there was a job on the Ohio River in Cincinnati area, and I was asked to comment on some of it because they were looking at row cap tests. They were having dry fasteners during the row cap test, but then they told me they installed everything with the bolt heads out. On a galvanized bolt, how do you solve the solution on bringing your torque down? Any comments, any ideas? What do you lubricate? The washers, exactly, because that's the easiest piece to lubricate. It takes the least amount of lubricant. You don't want to stick your bolts in and lubricate the whole bolt when all you need is the turning surface lubricated. So you lubricate the washers. I suggested that, and what I suggested is you take 3 samples. Do the first one, put it in the Skidmore and turn the nut on the bolt with the nut sliding on the washer. Next, put the bolt in the Skidmore backwards with a washer out front and the nut on the back, and install it and record the torque at, say, 50 kips. Do 50 kips this way and then do 50 kips the other way with the dry washer. Then do the third sample with a lubricated washer, turning the bolt head. And it was interesting. The people managing the project and the contractor did that, and they called me back in about 2 or 3 days, and they said, "Thanks, Jerry. We're lubricating all of the washers on the entire project because all the truss members on this river crossing were narrow enough that the bolts had to be with the bolt heads exposed on the outside. They couldn't get a wrench on the nuts. So all the bolt heads were outside, that they turned all the bolts in that entire project. And they said that's going to save them a bunch of time and a bunch of wear and tear on the wrenches. So it's ideas like that that can help people, and you got to look at that. But this is the big this is the big issue on what costs you money. If you don't have lubricant in here, 70% the friction's back here, even with lubricant, 30s in the threads and 70s here. Well, if you put the turning over here and there's no lubricant at all here, then this drops down to next to nothing, and most of your friction's right here. And it's tough to get that rotation. So it's little things like that that can help the project. And That's why I like contractors in here, because they can see what benefits them, and if they see something and they have an idea, it's better it's discussed in here amongst everybody, then everybody gets that understanding of what's being faced or what the problems are. Slip critical connections, we rely on the friction in the connection between the plates. They're either whoops, we can't go here. You've got a blast clean requirement here or a Class B coating in a slip critical connection. You've got a requirement to give you friction in this connection. For those of you that are designers, the specification requires that you can design for friction as a slip critical connection, but you also have to check that connection for shear. So if the connection does go into shear bearing, you've got the capacity to cover you. Typically the frictional govern. The other thing that's important in these connections, you've got in shear bearing connections, and if you're checking a connection for shear bearing, even a slip critical connection, we've got bolts, and you don't see this as much on bridges as you do on buildings. You've got X bolts and N bolts. It should be X connections and N connections, but they call it X bolts. So if the plies bear on a bolt shank, like here, this is an X connection. The threads are excluded from the shear plane. If, for example, you have a thin plate and a thick plate, if you got the thin plate and the shear plane was here, it would be an N bolt, or the threads included in the shear plane. If you'd wanted that to be an X connection, and this is a thin plate, the bolt would have to go through the other direction, so your shear plane would be in the shank of the bolt. Now if you get into that situation and you force somebody to, say you got a half-inch plate and a 2-inch plate, and you got a short bolt in there, but the threads are in the, if you had bolt one way, it'd be in the shear plane, and the other way it wouldn't. Then you'd have to specify that the bolts go in one direction, and so then when you're inspecting, you got to make sure that those bolts do go in the right direction. It's an added problem. But anyway, those are the kind of things, and we run into that on that big auditorium. We had situations where there are X and N connections, and you got to look at that and see that they've got the design addresses that. Bolts in direct tension. Anchor bolts are typically in direct tension. This, another one that's I like to use as an illustration is these pre-engineered buildings. See them like Butler buildings, got a column up here, they're bolted to a roof system. In the center of the roof, they got a connection like this. You got a plate on the end of that member, and there's 4 or 6 or 8 bolts through these 2 plates like this. So when you load that plate, load the roof with snow, the roof wants to come down and those plates pull apart. That puts direct tension on those bolts holding those 2 halves together, 2 halves of the roof system. That puts them in direct tension. If you've got a bolt in direct tension here, you're pulling on this. If we put, say we got some bolts and we pre-tension these to, let's just say we put 20 kips in these bolts. We pre-tension them to 20,000 pounds each. They're smaller diameter bolts. We got 20,000 in each bolt. And I pull on this bracket. How hard can I pull on this bracket before I stretch these bolts if I got 20,000 pounds on each bolt? I pre-tension them to 20. When will they start stretching? On bolts, if, what? Over 40. If you pre-tension a bolt to a given tension, if I pre-tension them, I got 20 kips on or 20,000 pounds on a bolt, it will not stretch until I load it greater than 20,000 per bolt. So I got 2 at 20. If I pull down on it, they won't stretch any further or pull those plates apart until we exceed 40,000 pounds on this situation. So if we preload these bolts in tension on on slip critical joints, we don't get into that because our joint typically we got a web here. Here's our web. for example, and here's our splice plates. We don't tension those bolts like this. We don't load them like this. We're loading them like this. So we don't load that bolt in direct tension in a standard bridge joint. We're loading them, that load in that bolt is in this direction. It's not pulling on that bolt. So we aren't adding tension or trying to load that bolt in direct tension. We're loading it in shear bearing. And we've got the friction between the plates so that it won't slide. But where we get into direct tension, we're loading the bolts, but we got to look at how much tension we need on those bolts to address the maximum load we ever put on it so we don't stretch the bolts. Fang surfaces, we got Class A, which is clean mill scale or blast clean steel with a Class A coating. Class B is bare blast clean steel or blast clean steel with a Class B coating. And then we got Class C, which is hot dip galvanized, that's roughened. This is typically what we use on bridges. And for a paint system, we're allowed to put a paint on it that's tested as a Class B coating. And there's the requirements are covered in the Research Council spec. There's a section in the back of the Research Council that talks about how they test for this. And if you're putting on zinc-rich primer for these connections on a bridge structure, they test that paint. You've got a certain paint that you're using, that this department uses for as a zinc-rich primer. And let's say that paint can go on minimum of 2 mils, maximum of 4 mils typically is what, let's just say that's what's used. They have to put that paint on test plates 4 mils thick, the thickest allowed spec, or the thickest amount that's allowed in the specification. They paint these test plates and then they load the specimen. There's a in the back of this Research Council spec, there's drawings illustrating how they test them, what's required. There's a procedure for doing that test in the Research Council spec. But they have to test the paint in the thickest condition that's allowed in the design. Class C, hot dip galvanized. If you got galvanized girders on a bridge, if you do a galvanized bridge, and you galvanize the girders, you have to roughen those connections prior to bolting them up to get a slip critical connection. The roughening is done by like a grit blast using walnut shells or a light brush blasting with hand wire brush. You cannot power brush hot dip galvanized structures and bolt them together to get slip critical because power wire brushing polishes the zinc rather than roughening it. So it has to be either like a grit blast with walnut shells or something on that order. Sandblasting would take all the zinc off. So there's some requirements that have to be followed there if you do hot dip galvanized structures and you want a slip critical connection. On slip critical joints, these circles around the bolt holes on plates up to 3/4 or slightly above it have to be clean around the bolt holes. That's what gives you your slip resistance. You get over 7/8 of an inch, get up to thicker plates, the plates don't flex like the thin plates do as you bolt them up, and you can pick up slip resistance in those areas, the shaded areas around the bolt holes as well as at the bolt holes. When you get into thick plates, 2, 3, 4, 5-inch plates or thicker. We had a bridge on the Mississippi that had 2 5-inch plates bolted together. And they could see the bolts after they tensioned the bolts. They could see the bolts between the plates. The the rolling tolerance on a 5-inch plate is about 3/30 seconds out of flat. So you get bumps and dips in the surface because you don't roll it smooth. If you roll a plate down to a 1/2 inch, you gets almost as smooth as this table, but a thicker plate, until you roll it down thinner, you don't get that smoothness. You got to allow, the thinner the plate gets, the smoother the plate is during the rolling process. When we got these dips and bumps, that's allowed in the thicker plates. So then you bolt them up and you got gaps in it. If you got a 3/32 out of flatness tolerance in a 5-inch plate, you put 2 of those dips together and you're going to have a 3/16 gap between the plates. And this happened on a cable-stayed bridge over the Mississippi up in, I think it was in Alton, Illinois area on the Mississippi. The bolt gurus looked at it. They said, well, we got enough friction between we got enough area and contact between the bolt holes that we have a slip critical connection, but we've got gaps. So how do we solve it? It was all erected. The solution was you epoxy putty around the joint, around the connection to seal it, put some vents in it, and you inject it with soft epoxy and plug it so that water can't get in. The bolts were all properly tensioned, but it kept the water out long term for the project. And then you paint the bridge and hopefully it'll last many, many years because it's not going to slip because you got the slip critical connection.
Would that steel eventually malleable so they would come closer together?
It can't come together. When you get a 5-inch plate, it's not going to flex. If you got a, it's like, it's like putting and if you hold your hands like this, you can't get your fingers in total contact in this area. There's going to be a gap because it's out of flatness. There's an out of flatness tolerance. So how do you pull that together? If these are thick steel plates, you can't pull that dip out of there. They're in firm contact from bolting standpoint because you can't pull them any closer together. The bolts aren't strong enough to pull that flat. If the surface isn't flat, you just can't pull it out of there. So there's no way you can pull them together. They're never going to come together. So you got to fill those gaps. They could have planed the surface prior to fabrication. That would have been the only solution. This amount of overspray on painting, if you're top coating in the shop prior to erection of the steel, and that's what they were doing on this auditorium that Ryan talked about. They top coated the steel with their, it was a hard epoxy type paint they were putting on this steel. They painted in the shop so they didn't have to paint in the field. And they didn't only overspray, they just painted everything. They didn't mask anything out to stop this. But this amount of overspray, this amount of sand or dust or blowing on a job, or have you guys seen steel girders being assembled on the ground? They set up a couple lengths of girders, they bolt a splice up, or they got them sitting there on the ground and then they put them together before they pick them in the air, or they sit on the ground on some 12-inch timbers. They got the splice plates laying there and the dirt splashes up in the rain and there's some dirt on the structure. Clean that dirt off before those splice plates are put together, before they pick it in the air, because if this stuff is just sand and light grit between the splice plates and the girder flanges, whatever, that will destroy the slip coefficient in that connection. Now, to give you a feel amount of overspray this is, we don't have any women in here that are going to give you guys a hard time, but your wives aren't here. But what I want you to do tonight when you brush your teeth before you go to bed, get your toothbrush all nice and foamy. Then you take your thumb on your toothbrush and the bristles and you run your thumb over it and squirt it on the mirror. And you got a spatter about like this. And you leave it on the mirror and you tell your wife, we learned this in the bolting class today. Just don't tell her where I live. But that's about the amount of overspray it takes. It doesn't take a lot. Snug tight on the joint. Now, in 2009, we had this specification. Let's see, we got tightness when all plies are in firm contact, nuts cannot be removed without a wrench, full effort of a worker with a standard spud wrench, approximately 20 to 30% minimum installation torque or a few hits of the impact wrench. That was our spec back in 2004. In 2009, we eliminated this bottom portion. Said, okay, tightness that applies when all plies are in firm contact, nuts cannot be removed without a wrench. What happened, if you do that, this indicates that, okay, if you got it finger tight to the point, or it'll just be on finger tight and not 20 to 30% or a few hits of the impact wrench or a iron worker with the spud wrench, full effort of an iron worker. These bolts weren't tight enough. If you match mark them and did turn of the nut, you didn't get the required tension under the turn of the nut method. You needed more tension. But we wrote that spec in the 2009 specifications, this part of it, and eliminated this. Last June, at the Research Council meeting, we got a real issue, and we got a new spec that came out. This just came out in December. Brand new spec. It's going to be in the new AISC steel manual that comes out early this year. We put this back, the rest of it back into the spec because we weren't getting enough snug tight. The snug tight condition wasn't high enough to make it work for turn of the nut method. So it's now including all of this. This is all back in the specification. We screwed up the spec in 2004 and we fixed it in 2009, and we fixed it this past fall in 2014 before we published the new book. We want to remove the gaps when we snug. We want to get those plies pulled firmly together. Here's the situation. This is a sign structure. You got a gap here. There's a 4-bolt connection. You ever see any of those in the state? These are bolts that came out of an adjacent sign structure. They fatigued. Here's the structure where that picture was taken. This is what it looks like. We got a gap on the top. There's a gap in that in that bolted connection there. It's touching at the bottom. This structure was up here. Same basic length as that one, over 4 lanes of traffic. With that gap in there on the top, with the wind, that arm was going up and down in the wind. That arm will oscillate in the wind. Every time it goes up, there's zero tension on the bolt. When it comes down, it's tensioned. What does that cause? Loading and unloading the tension in a bolt creates, that's your fatigue loading. This sign came down. How long do you think it took for that sign to come down after it was erected? How many years? 3 weeks. 3 weeks. And it fell into the highway. How many people do you think it killed? It fell at 1:30 a.m. in the morning. The bridge maintenance people saw it sometime before and they said, you gotta fix it, we got a problem. And a week later it hit the street at 1:30 in the morning. Fortunately, there was no traffic. This happened in Eau Claire, Wisconsin, a couple of years ago. Not a good situation. You got to get those joints tensioned. Thick plates and plate warpage, we talked about that. Systematic tightening, you start in the middle and work out like that. I've had states in the past that required that you number the bolts through the connection. That's not necessary. You start here in the middle and you work to either end. And you go through that process one time. AASHTO requires, state highways are required by AASHTO specs. You snug through this connection and you go back and hit it a second time to make sure that everything is snug before you do final tensioning. That's required in the AASHTO specifications. That says it's required in the state specifications. Threads in the grip, we talked about that. 3 to 5 threads in the grip, we talked about why it's required. The more threads in the grip, the better that bolt performs. You get a flatter curve, more ductility in the bolt if you got more threads in the grip. And we talked about that first thread in the grip being the highest stress thread. This is one that I got a bunch of grief from our Washington office and from one of the guys in our Washington office who was a welding specialist, or thought he was, maybe, I don't know, but he doesn't work for Federal Highways, retired now. But I said, you know, you need to look at this when you're doing inspection. You get out there and you look at a connection before you do your final inspection. And you look for anything out of the ordinary. That bolt we got the arrow by looks like the stick out is a little bit more than the rest. These had DTIs on the backside under the bolt head. Was the DTI left off here? What happened? Why does that bolt look longer than the rest of them? It looks like it's missing about 1/8 of an inch, or 1/8 inch longer. Why is it different than the rest? All the bolts were from the same lot. They were all the same length when you started. They should be the same length when you finish tensioning. Did they just over tension it? Who knows what happened here? But it's a good it's a simple thing. You're out there inspecting and okay, this looks pretty good, except we got a problem right there. What's the deal here? Why doesn't it look the same? Just one of those things. It's one of those things. It's just common sense to walk up and, hey, that doesn't look quite right. What's going on here? Related to this, when I was in Kentucky in the 70s, they built a truss over the Ohio River. They were putting bolts in, and they got everything bolted up. And the iron worker said, wait a minute. We got a problem on this bridge. There's some locations that had a lot of bolts that were let's say they're all 4-inch bolts. And they said, we've got a lot of connections. They're all the same length, but we randomly have some bolts scattered here that are 1/4 inch longer than the rest. Well, there's a 1/4 inch allowance, so, you know, your bolt length step typically up to a certain length in 1/4 inch increments, and then they go to 1/2 inch. But the iron workers came to us, and they came to the state. And I was out there oftentimes on the bridge, but they said, you know, they don't look, they all started out the same. Why aren't they the same now? And so they got checking, and they found out that the bolts that were a little bit longer had stretched during tensioning. So they went back to the manufacturer, and they found out, tracing the paperwork, that there was a production lot of bolts that got shipped to the field to 3 different states that had never been heat treated. They were still annealed steel. They hadn't gone through the heat treatment process. And they traced it with the paperwork from the manufacturer through the distributor to 3 states, and they recovered all but 100 bolts that had been shipped out to these 3 different states. And they said those 100 bolts were probably bolts used for testing or maybe dropped in the river or whatever. But the paperwork traced it, and they found out that they had not been heat treated. We don't see that very often, but it was good to see. This was back in the early 70s, mid-70s, and the paperwork showed that they weren't, you know, they had a problem, and they didn't catch it before they installed them, so they had to replace them all. But they should, if they're all the same when you start, they ought to all be the same when you're done if they're installed properly. So this is just not a requirement, but it's just one to trigger. Okay, we got a problem here or we don't. Bolt holes, types of holes, standard holes, oversized holes, short slotted holes, long slot holes. You've got standard sizes in the specifications. These are in the Research Council spec, included in AISC steel manual. And along with holes, we're talking about washers. There are beveled washers that you can use if you got a slope exceeding 1 in 20. And typically, like if you had to put bolts through an I section or a leg of a channel, you'd have beveled washers in that connection on that slope. Hole types and these are in outer plies. We put this table in here. This comes out of the Research Council spec, and it talks about what can be used, like A490 bolts. Got long slotted holes, you got to use an F436 washer with either a 3/8 plate or a washer or a 3/8 thick plate washer or a continuous bar. The other thing, once in a while you'll see, here's a 5/16 F436 washer. You got thicker washers than standard sometimes. This is a plate washer, but it's not 3/8 of an inch thick. It's that type of thing you're looking at here for these, but it's a 3/8 inch thick plate here, or a continuous bar. You'd use a continuous bar if you got multiple holes. We put those charts in your book so you've got them as a reference. How is load transferred in a slip critical connection? It's transferred by friction. Why is it necessary to remove faint or foreign material from fang surfaces? If it's overspray, like from vinyl paint or polyester, or acrylic, that destroys the slip coefficient. You can have your sink-rich primer, but there's other paints that aren't allowed in those connections. Why is snugging and pulling the plies in firm contact required? Because if you're doing turn of the nut and you don't have firm contact, those plies are going to move together and you're not going to get your tension when you do turn of the nut method. So you've got to have that done. You've got to have that firm contact before you match mark and do your turn of the nut. When snugging a large splice plate, what sequence should be used? Start in the middle and work out. And then go over it a second time to assure that you got all the bolts snug. What type of washer can be used on a long slotted hole? 3/8 plate, or a plate with a slot or holes covering a series of bolts in a row that are, if you got a row of slotted holes, you put a long plate on with holes that match the bolt spacing. When are beveled washers, or where are they required? You got a slope greater than 1 in 20. Typically you don't need that in structural applications other than where you've got a channel or an I section. We don't use many I sections on bridges. We usually use rolled wide flange sections. This is in our front yard. We'll just move on here. You don't want to sit and look at that buck in velvet in August. That limb came out of the apple tree right behind the buck's butt. There's about 300 to 400 apples on the ground, and this summer we had multiple pictures from the trail camera down by our garden taking those pictures. There's as many as 6 deer out there at a time eating apples. Kind of fun. Installation methods. You ready? Yeah. You want to? Why don't we just give you this and I'll follow you around and carry it.
Whatever works.
Okay. Don't hesitate to ask questions if you got them.
Yep. All right, so this section we'll talk about the four main installation methods. Before we start, we'll just touch on the tension-torque relationship. This comes into play with the, what is it called? The tension control bolts. So a 20 kips is going to get you 150, it'll take 150 foot-pounds to reach that. 40 kips, 300 foot-pounds, and this is while it's still in the elastic range. Once it goes inelastic and it starts to deform, this will not be true, but while they're in the elastic range, it is. Also, the longer the bolt, the more torque is going to be required to reach that tension. So for a 4-inch bolt, let's say you're going to go to 18 kips, it's going to take 160 foot-pounds. If you have a 7-inch, it's going to take 170 inch-pounds. And this is also foot-pounds. What I call them? Inch-pounds?
Yeah.
Oh, that's wrong. Foot-pounds. So you want foot-pounds in there, and that's in the tension control bolts. This is a major issue.
Let's go back to that 1 minute. The reason I put this in here is that the TC wrench has a fixed torque tension relationship. And if you got a short bolt, they put a different lubricant on a short bolt assembly than you do on a long bolt assembly so that you achieve the required torque or required tension. With a short bolt, you don't need let me turn that around. If you got a long bolt, you got to have a more higher lubricity or a better lubricant than you do on a short bolt so that you get the same tension for a given torque. So you can't switch on a TC bolt. You got 3-inch bolts and 7-inch bolts. You can't trade nuts. You can't put a 3-inch nut from a 3-inch assembly on a 7-inch bolt because you won't get the right tension. that's why I put this in here. It's really referencing that TC bolt. You can't switch, the nuts have to be, and they're shipped as assemblies, and they have to be used that way. Okay.
All right. We'll talk about the 4 main methods of installation, the differences between them, the pre-installation steps for each of those 4, and we'll find that they're all very similar. And then we will not be performing a pre-installation test for each installation method. We'll be discussing them. So the 4 methods are turn of the nut, the calibrated wrench. We're really going to fly through. Does anybody have any experience with calibrated wrench or seen it been done? Yeah, we'll breeze through that one. It's kind of fallen out of favor. The twist-off tension control, which is the one we were talking about with that torque-tension relationship. And then DTIs, which is what all of you guys are familiar with, correct? Okay. So turn of the nut, there's no specialized equipment needed. You can use air, hydraulic. You can use the wrenches like we are up here. So the installation process, it's similar to a row cap test, just some of the values are different. So for snugging, it's not 10% like we did with row cap. It'll be 20 to 30. You don't want to exceed 50% though during this process. You'll then match mark the bolt. This is important because you're going to do a rotation of the nut, not as much as the row cap, and we'll show that in the next table. One thing that can come in handy when you're doing inspection, if after they're all installed, all the match marks are perfectly on the turn, that means that they probably did it after installation, and we've ran into this a lot. You want to do it before installation, so be careful if every single one is perfect. They did it incorrectly, or else they're very good at turning the wrench, one of the two. So as you can tell from the row cap test, this is about half of the rotation that you're getting in the row cap is for turn of the nut. And once again, it's for up to 12 diameters. They have the turn. Past that, you're going to want to use the Skidmore. What's important with this, if you're having 16, 17-inch bolts, which for that truss that we've been showing, that's what they were using, you're going to have that, and it's going to be sticking out very far. The Skidmore will work for that. You want to use something to prop up that bolt, because these 2 little ears right here can easily snap off. I know Jerry's seen a couple, and the people at Skidmore have had to replace a bunch of them. So just be careful with that, but you can use up to any length and use the washers, and they sell special little bushings in there so you can stick them out as far as you need to. So just like all tensioning, it requires the elongation of the bolt. That's where it gets the tensioning from. For the pre-installation verification, so the row cap test is to ensure that that assembly is working properly. The pre-verification is ensuring that your method is getting the proper tension. So you're going to take 3 assemblies from each lot, and then you're going to verify that it is hitting 105% of the minimum tension. So for that 39 kips, it needs to be hitting at least 41 kips. So the pre-installation is much like the installation. You're using the Skidmore. You're going to install it in the fastener. You're going to, into the Skidmore. You're going to snug 20 to 30%. Do not exceed 50%. You're then going to match mark it, turn it the required, whether it be 1/3, a half, 2/3, or if it is longer, whatever the Skidmore says is required. And it has to meet or exceed 105% of that minimum tension, depending on the size of the bolt and the length. So for the example, A3 25 7/8, for that minimum of 39, you need to at least hit 41. And is that average or the minimum of the lowest? Is it the average of the 3 has to be?
Each one of them has to hit it.
Each one of them. So all 3 out of the 3 of them, all of them have to hit 41. So here's an example of one of those big TC bolts that they were using down at that Epic project, which is with the huge truss. So this is for something like this, you'd want to use a Skidmore to figure out what amount of turns you're going to need to hit that tension. The calibrated wrench isn't used anymore. I've never seen it. Have you ever seen them used?
Yeah, I saw it.
So
They don't use it anymore.
they don't use it anymore. It is incredibly time consuming, and it requires 100% inspection. So you have the adjustable air wrench and the non-adjustable. The non-adjustable is not permitted for use at all, and the adjustable air wrench is. Here it is. You just have an Allen key at the top to adjust the amount of torque you're putting into there. So you're going to use a Skidmore. Manual torque wrench, they give you torque tables, which you're not allowed to use. You have to use a Skidmore to figure out and to calibrate the wrench, exactly what you need. I guess, does it say right? Yeah, so you have to recalibrate every day whenever a new iron worker is installing. If you're changing the lubricant, if anything changes with the lubricant condition, or the thread condition, if you have a different lot, if you're changing air compressors, hose length, for any reason, you have to recalibrate it with the Skidmore, which is why nobody really uses it. For the installation procedure, you install the fastener required with the washer required under the turn element, snug, similar to the turn of the nut, 20 to 30, not to exceed 50. Then you'll tension it in a systematic sequence with that calibrated wrench, and then you touch up after tensioning. We already went over this slide, when you're going to have to recalibrate it and why it's so time consuming. Pre-installation verification is the same as turn of the nut. You're going to use 3 assemblies, use it in the Skidmore as you would have been installing it in the joint, and all 3 have to meet or exceed 105% of that minimum tension. Yep, and here's all the steps in there that we just talked about. So use all 3, snug it, and it has to 105%. For the twist-off bolt method, are you guys familiar at all with that? Do you guys use that in Minnesota? A little bit. I know they use a lot in buildings, so I was around it on that truss and a little bit in bridges. So here's what it looks like. Where is that?
It's right over here.
Oh, right here. So here it is. There's a little spline at the end. When it hits the appropriate torque, this will tear off, and you can't tighten it anymore with the specific gun. So that's a... And as we were talking with that torque tension, you have to use every part of that assembly as it's delivered. You can't mix and match anything with that.
So you have to have a specific gun for that.
There is, and it's a gun that looks like this that'll fit on there. It's specific. You can use a air wrench for snugging. You never use this gun during the snugging procedure because you can take off the spline, and if that happens, you have to remove it and replace the bolt. If it is raining outside or if there's any kind of inclement weather, the lubricant can work too well and you'll break the bolt in tension because the lubricity is just going to get so high. So you have to be very careful to keep the lubrication exactly like it is upon delivery. You cannot relubricate these bolts. You have to send them back to the manufacturer to relubricate. Do you have a question?
What's the price difference between the twist-off bolts versus the DPI assembly?
Probably with the bolt and the DTI, it's probably comparable. You figure the bolt and the DTI, the twist-off's probably close to comparable to a standard, but it's a little more, they're both a little more expensive than just the standard hex bolt doing turn of the nut method.
And in situations where you can't get that gun on there, you can use turn of the nut method on these. So then that's the only reason the spline would still be on there. So here's how the gun looks. So one part will hold on to the spline, one part will hold on to the nut. It'll turn the nut clockwise and the spline counterclockwise. So when it hits that torque, it will torque off that spline and it will not be able to move the nut anymore. So that's how that works. Here is just a diagram on showing how it works, and the spline right there after it's fallen off. Yep, so it'll take the nut clockwise, that spline counterclockwise, and that's how it works. And since it only has one, do you recalibrate it for every length, or is it all bolts have the same torque, correct?
They're all the same torque.
So they're all...
You still calibrate each different.
Yeah, you still calibrate. Yep, so once it hits that specified torque, that's when it'll take it off, which is why you can't switch them. Installation process, you put it in there, you snug the joint 20 to 30%. You can snug with an air wrench, never snug with that the TC gun. And then you hold the trigger and you tighten it until the spline twists off. Pre-installation verification, 3 assemblies, 105% minimum tension. Just like the other 2. Install the fastener, tension with an air wrench to 10 to 20%. And then you need to verify after the tensioning that it's hitting 105%. That's the same for all 4 procedures. And now the DTIs, which is what you guys are used to in the bridge world here. You cannot have nil gap. Does anybody know the one exception to that rule? If they are galvanized, you are allowed to have nil gap. And they are now starting to use these with ancillary structures in Wisconsin, and we've been going back and forth with this a lot with the nil gap with galvanizing and just having a lot of problems with the installation of them because a lot of the contractors are new to them as well. So you cannot have nil gap unless it is galvanized. It prevents over-tensioning, and you cannot use in conjunction with turn of the nut method. You can use this with the tension control bolts to ensure that they're achieving that proper tension. So you can mix and match those 2. here's what the DTIs look like. And you guys do not use the ones that have silicone in them, the ones that are called the squirters that, okay, so you guys don't use that. The main point with those, if you guys ever were to, you can't use those for inspection afterwards. If you are present during installation, they can be used, but since they're so light and it's that light silicone, it'll blow away with any sort of wind, so you can't rely on those. It's more for the installer to know when they were getting compressed down. And yeah, okay. Yeah, I didn't keep going. So yeah, you have to use the feeler gauges, just the same as the other ones. So this is what we're talking about with those silicone, the squirters as they're called.
I'm passing one around.
Yep, so you'll be able to tell the one there's just going to be the silicone in one of the ones that's being passed around.
Dry silicone, cured silicone, so it's dry. And when it pushes out, then it blows away in the wind.
Yep. And there's,
So
yes.
we were told that with those types of squirters that because we paint most of our girders, that the paint won't adhere, that's why we don't use them.
That silicone blows away. If you pressure wash your steel,
Should go.
that silicone's gone.
Somebody-
Problem is when that squirts out, it's dry silicone. And if you got any breeze out there, it's gone no time at all. It's out of there. It blows away. It's dry and hard.
Yeah. Somebody did mention that yesterday though about the paint.
Yeah.
I know.
But it's not gonna be a problem.
Okay.
But the company says you don't need to do any inspection, and that's not the way the specs are written. You've gotta inspect with a feeler gauge. It's only
Unless you're there observing it at the time of.
Yeah, and it's well, you still need to check with a feeler gauge to make sure that they're consistent with it.
Yep, so we recommend using feeler gauges regardless, whether you're there at time of installation or not. And these can be either forged or pressed. And one important thing,
They're all pretty much pressed out.
they're all pressed? Okay,
Yeah.
never mind. These are not washers. They do not take the place of a washer. They are a load cell. That is another big important thing with DTIs. You have to still use the washer as required. You can never put the DTI towards the structural steel. The reason is these bolts are going to be around 120 plus KSI. That structural steel that you're using is going to be 50 KSI. So it's going to be a third the strength. Those DTI bumps can just push straight into that steel, so you never want to put them towards the structural steel. So here would be underneath the bolt. Then, yep, so you never want to put it under the, or pushed into the structural steel. You can put it into the washer, or you can put it into the nut. And that's, is there a specification here differently that you cannot put it into the nut? I know there's,
Most nuts are heat treated, and they aren't gonna press into the nut. You got DH nuts, it's very rare that you're ever gonna see a non-heat treated nut on structural steel anymore. If they're galvanized, they're heat treated. So the bumps can be against the heat treated nuts. Even though it says, what?
All of our literature says you have to have a washer on there, otherwise you're just gonna spit those.
I know.
and this is,
But if you're turning for example, if you're turning the bolt head, they can be against the nut. And the nut's hard enough that they aren't gonna compress in the nut. Typically, if you have to put them under a nut on a turned element, when the bolt head is turned, then you've got a situation, you put them against the nut, you don't need a washer between the nut and the and the DTI. That's what we're talking about, okay?
yeah, but we talked about that. You guys are required though to put them under the washer though anyway, correct? So
Yeah.
for oversized holes or large bolts, with a larger bolt, is it at 1.5 inches that the hole goes from a 1/16 to an 1/8? You have to use a special type of washer, or else the bumps will just press themselves through that oversized hole, which is what.
I'm sending a sample around of 1 1/8 where the DTI was on an A490 1 1/8 bolt, and they tested it, and it pressed into the washer hole, and it sunk into the hole, and when the bumps were totally flat, that bolt only had 90% of the minimum tension, because so much of the DTI squeezed into the washer hole. This is a situation that solves that. You put a plate on it with a hole that's 1 1/8 or a 1/16 larger than the bolt, you put a plate on it like that, then the DTI over that, over an oversized hole, and then a structural washer on top and tension it. Just kind of a DTI sandwich.
Yep, so pretty much the hole has to be a 1/16 inch larger. It cannot be any larger or the DTI will not function correctly. Basically, the easiest way to think about it, as well as the DTI does not replace the washer, so you have to follow all washer requirements, as Jerry talked about in the bolted up joints. So pre-installation verification test, exact same as the other three. You need 3 assembly lots, and it has to meet or exceed 105%. So for the installation, you install the fastener with the DTI positioned correctly. You snug tight 20 to 30%, don't exceed 50%. Use whatever method you guys use or are able to use given the requirements. And then you guys will, for Bridge World, you're going to use 5,000ths. For buildings, they typically allow 15,000ths, but for you guys, I believe your feeler gauges will be 5,000ths for most. You cannot have nil gap unless it is galvanized, and then it can be nil gap. All right, does anybody have any questions with the DTI? What were some of the questions raised yesterday by the specification, the guy that was in charge of that? Because we talked about, was there anything else about
DTIs being
nil
taken
gapped?
out, nil gap.
Yeah,
There's a lot of discussion on nil gap.
Yeah, I think they're going to change some of the wording in the Minnesota DOT specification to kind of clarify the DTI nil gap, because that was a large issue yesterday. Okay, so what are the 4 methods? Turn of the nut, yep, calibrated wrench, which isn't used, direct tension, TC tension control bolt, and then DTIs, which you guys are most familiar with. Are the basic steps for tensioning the same? Relatively, yeah, you're going to snug it 20 to 30, not to exceed 50, and then do whatever installation method requires after that. The pre-installation test requires to meet or exceed what percent? 105%. Why are the bumps on the DTI not placed against the structural steel? Softer, it's much softer steel compared to the structural bolting assembly. What are the cons for using the calibrated air wrench? Just the amount of calibration that's required for, if anything changes, you have to change the settings on it and recalibrate it with the Skidmore. So it's very, very time consuming. You want to talk about your bridge?
What's the next section? You gonna take it or?
Verification inspection? You can do this and I'll do the last one. You want to take a break?
No,
Yeah?
I'm not gonna take a break yet.
Just going to power through.
I wanna do 2 things here.
You want this?
Brian said we weren't gonna do. What do we got here? Brian said we weren't gonna do pre-installation verification. But I decided I ought to do that for you, just to give you guys a better feel for it. So what I'm gonna do, I got a 7/8 plain bolt here, 4 1/4 inches long. So I have to do a half turn on this for installation, right? It's greater than 3.5 inches. I'm gonna do one pre-installation on turn of the nut, and I want to do one on DTIs. How many of you have seen the pre-installation verification on DTIs? Anybody? Have you done pre-installation verification on DTIs? Well, I want to show you what's required, just in case there's a misunderstanding or anything else. Huh? Yeah, if you want to pull it. Yep. Well, spud wrench first, 20 to 30%, so about 10, 12 kips. Ryan didn't know what he was getting into here. Keep going, I'll tell you when to quit. Keep going, you're at 10, a little bit further, let's go some more. We got to get 12 kips.
That's probably good, isn't it?
Ah, you're 10 kips.
Yeah, that feels
You're good. Okay, now match mark it. We got to do a half a turn on this. So we're going to put the marks over here. It's about here. Oops, that's good mark, isn't it?
A little abstract.
We don't really need a mark on the faceplate. Okay. We don't need the torque wrench. Use this one.
I'll do it with spud.
So we got to do a half. We snugged it. We got 12 kips or 10 kips. We had 10 kips, and then we got to do a half a turn. Keep going. Man, my mark is all screwed up. Should I trade places with you?
No, it's all right.
Keep going. You're not half a turn yet. We got to do another. Come over on this end, Ryan. Let me look at where we are. Let's see. Here's where we were. So we got a 2/3 of a turn, or a third of a turn. Here, give me the wrench, and you go on the other end and hold the back end down.
All right.
I got a lot of lead in my butt, so I think. We're almost there. I picked a good bolt here. We got a half a turn. We've got 56 kips on a half turn. This is pre-installation verification. So out of this 7/8 by 4 1/4 inch bolts, we got 56. Minimum required was 39. So we're about 30% or so, maybe a little over 30% above the minimum required. 56, that's 17 kips above the minimum. We're up there pretty good. Okay, now we'll take it out if you hold the other end down. And that's all you have to do for turning the nut. You do 3 samples. You don't need it. You can do this with an air wrench. On turn of the nut method, you can install them in the Skidmore with an, snug them and then install or do the final rotation with an air wrench. You don't have to do it with a torque wrench there's no torque readings. You don't have to do it manually.
And the one question from yesterday is when you can do it. You can do it whenever you think the condition has changed. So if they've been snug tight in the joint for 3, 4, 5, 6 months, and you think that lubrication might have dried out, you can run this test to see if you guys need to re-lubricate the assembly.
Okay, DTIs. Who's run a DTI installation verification? Anybody? Have you seen them? Nope. Let's do one. I got a galvanized bolt here. Are the DTIs back up front here? You seen them? I'm going to take this one. Got to have one more supply out of here. Yeah. Here we go.
Circular effect.
And then I'm going to put a washer under here because the indentations, let's see here. Oh, we can see it okay. We don't need a washer on the front side. Now, what the requirement is, I've got to compress this down. I got to take it to the point that I've got three. I can stick the feeler gauge in on the front at 3 locations. And that should be 3 open at 39 kips. Or I'm sorry, at 41 kips. At 41, I should stick the feeler gauge in at 3 locations. So, we're going to pull this down to 41 kips. And yeah, let's do it with a torque wrench on the back going the other way. We got to turn the back, but go to the other direction. Hopefully we can make it work. You got room to not hit the screen? Yeah, I'll stop you at 41. 2, about 10, 18, 28, 27. Okay, now I'll go slow. 39, 30, well, that's 37. Keep going. Here's 39, go to 41. Oh, just a little bit more. Stop. Now at this point, I should be able to stick the feeler gauge in at 3 locations. 5,000th feeler gauge. We're going to put that back on again in a minute. So it goes in 1, 2, I sure got a lousy set of feeler gauges here. I got it in 3, 4. It goes in all 5 gaps at 41,000. Now, in the book it says, on the procedure, you've got the procedure in the very back, Appendix A6, for checking them, for calibrating. And in the back, let's see, where are we here? Oh, this is A7. Take it down till you can only stick the feeler gauge into 2 gaps. Or on step number 5 on page A7, number of spaces that is refused should not exceed the number given in the table below. So if the test is a coded DTI on step number 5 under the table, it says if the test is a coded DTI under the turned element, well, we're not under the turned element. We're under, so we got 5 spaces. We should not be able to stick the feeler gauge in more than 2 of them. It's table number 5, the very under, way at the back of the book. Page A7 under Appendix A6. Go to Appendix A6, your tab Appendix A6, and then page A7. You're on page A7, and number 5 under the table, or in the table on A5. So at this point, we're going to turn it down till I can only stick the 5,000th feeler gauge in two gaps into the shank of the bolt. And right now I can stick it into all 5. So we've got to turn it down further, and I anticipate that we're going to be in the range of 50,000. Should we pull that up? Wait a minute, just a minute. There, get you a little more room to work. Okay, we're going to go up to about 47 or so, 48. Okay, let me check it now. We're at 40. We're about, shoot, we're almost 50. Let's see where we are. I've gone a little bit too far, but I don't know. I can get it in there. I can get it in. We might have gone just a little hair far. Okay, I can get it in. I get it in one. Went a little bit too much. So we're at, just a second here. 2, 4, 7. At 50 kips, we got one open. So typically, at proper installation, we're at about 49, 50 kips. If we'd have 2 open, we'd be at about 49 kips. So that's what would be the maximum. We'd expect 49 kips on this DTI with 2 open. We got 1 open and we're at 50, or just over 50, about 51, not quite 51. So that would be the tension you're getting out of this DTI, okay?
You could put the DTI on either, you could put it on the turn,
You could put it on the turned element side.
the washer if you want.
You could put it against, but it's better to put it under the bolt head. The reason to put it under the bolt head is if you've got a DTI on here under the turned element, are you getting the tension through the length of the bolt? You don't know. Because that bolt is binding in the hole. If you don't have that hole pinned, or the connection pinned so the bolts are free in the holes, if that bolt's binding in the hole and you put it under the turned element, are you getting tension in that bolt at the bolt head? You don't know. That's why it's better to put it under the bolt head or the unturned element. Turner sure keeps saying, oh, you can put it under the turned element. Well, you don't know what's going on if the connection isn't pinned properly and there's binding of the bolts in the hole. You're not going to pull that bolt forward to the turned element and crush the DTI back, or up here. You can crush the DTI up here, but you're never going to get tension in the bolt at the back end. That's why I recommend the DTI always be under the unturned element. That's where it ought to be. Turner sure is looking at it as an ideal condition, where the DTI is everything's working perfect. That's not the situation in the real world. When you tout it under the turned element, I mean, we had a discussion yesterday about pin connections and how many pins are in the connection and why you do it and why you don't do it and all of this stuff. And you don't have the connections typically pinned the way they ought to be so that they work perfect. So it should be under the unturned element. That's where it really needs to be. Okay, if you hold that side, or hold this side, well, all you have to do is, now you can put the spud wrench on it. That'll hold it. I'll put this on this end. We're going to take this out of here while we're doing this. Any questions?
So if it's on the back side, like you're saying, recommended, that would say you're doing a beam, that would be on the other side of the beam from where the guy is turning, using the impact, right?
Right.
So, I mean, they have to be really good at getting a feel for how long to get that done.
Well, we'll talk about that in a minute here. Okay. Okay, why don't you give me where's the speaker? Oh, I got it. Okay, I got it. Okay, guys. How do iron workers put bolts in the bridges? How do we tension bolts? You're doing turn of the nut. We got match marks on the bolts for turn of the nut. You got the bolt, you put a mark on half of the bolt, you put a mark on the nut, and there's a mark on the plate. The mark on the plate is optional. mandatory that you mark the nut on the bolt. So they get out there and the iron worker rotates the nut, but there's a white mark on the plate. Well, what is the white mark on the plate for? What does the iron worker use that for? Quality control. I'm getting way beyond for the iron worker looking. It's quality control. What do you use it for as an inspection process? You're the owner's representative. What is your process when you're looking at match marking? What is that called? Quality assurance. You want to make sure that they did it right. So the match marking is quality control, quality assurance. So, on DTIs, the iron worker's on the one side, he's on the front running the gun. He can't stand there with a feeler gauge and run the gun and stick a feeler gauge in there to check. So you got a guy on the back side with a spud wrench keeping the bolt head from rotating with a DTI on it. And he's got a feeler gauge. And you put the feeler gauge in. You know, the guy on the back side standing there holding the spud wrench, and they tension this bolt with the DTI and the bolt sticking through here. And you got 5 gaps. And you got to check to see if the iron worker's running the gun out there. How does he know when he's got the DTI crushed down about right? How do they do it? They what? But how do, you know, while they're turning the nut? You know, you guys are hitting it, but you aren't hitting quite what I want to tell you. Let me ask you, let me approach this a little bit different. We're doing turn of the nut method. And we don't get the snugging operation done right because they don't, you know, you're supposed to snug and go through a second time and snug everything, make sure everything's right, then you match mark, and then you hit everything with a gun, a third of a turn or a half a turn, whatever it's required. But let's say you find some during your inspection, you go out there, inspect and apply an inspection torque, and you find some loose bolts. If you find loose bolts, what do they have to do to tension those bolts? Do they match mark and do another third of a turn? How do they do it? Any thoughts? This whole process of retensioning, if you miss it, is by sound and feel of the wrench. You know, those iron workers work with it enough, and if you listen to them and you're out there, you hear it. That wrench has a certain sound when they get to the right tension, or close to the same sound consistently. So you get a feel for how that wrench is working by sound and feel of the wrench. Now, DTIs. We got a broken bolt here. Geez, everybody put all the nuts back on the bolts here. Gosh. So I got the DTI back here, and I'm on the back side, and I got the feeler gauge. There's an iron worker on the front. So this is in the hole, and I'm going to put the feeler gauge in here, and they run the nut up. When I can't get the feeler gauge out, I hit the steel with a hammer or a wrench, with the spud wrench, and tell them to quit driving. Then I rip the feeler gauge off because I can't get it out because it's tight. So we know that it's pulled up tight where it ought to be. The 5,000 feeler gauge still fits in there, but I can't just pull it out, so I leave it in there. So I can get 4 bolts out of a feeler gauge. So I got 100 bolts in the connection. I need 25 feeler gauges in my pocket for each connection. That's how you do it, isn't it? No, it's by sound and feel of the wrench. That iron worker on the front gets accustomed to it, and okay, it takes about the, you know, it sounds right. Then he checks with the iron worker on the back. He's, you know, taps the steel or something. The guy checks the last 3 or 4 bolts. Are they all good? If I got 2 refusals or 3, if I got 3, I got too many. I mean 3 openings, I got too many. I got to hit them a little harder. But basically, they're tensioning bolts by sound and feel of the wrench. And sometimes, you know, you got galvanized DTIs and the galvanized presses in, and maybe you can only get the feeler gauge in one. Some of them you might have a few that you can't get the feeler gauge in at all. Well, if you get a bunch of them in a connection, you start checking and you got 100 bolts in a web splice or 80 or whatever, and you start checking and, well, the feeler gauge doesn't go into 16 of the 80, that's 20%, or yeah, 20%. We got too many down to zero gap or no gap or whatever. Well, how much tension are you getting on them? You know, we had, what do we have on this one? 49 kips. Is that too much tension? If they're down to, I mean, you know, if I'd have gone to 52 kips, I'd have been zero tension. Is that really too much tension on those bolts? Can we live with it? Do we have to replace all of them? We don't need to replace them. Pull one bolt out. What tension? Check the torque on that bolt. Take it out, put it in the Skidmore, take it up to the same torque. What's the tension on it? It's going to be the same as what it was in the steel on that DTI. So we're at 52 kips, 53 kips. That's not too much tension. Leave the rest in there, but verify that you're not at 70 kips or 67 kips or way up over where you're up on, you know, you're good as long as you're on this side of the curve. When you start dropping down, you shouldn't be over here. We're plateauing around 60 kips on a 7/8 inch bolt. If you're on the uphill side, you're okay. Now it's just convincing the bosses and the top management in the highway department that that's acceptable. We talked about the same thing yesterday.
What was your answer?
Hey, that makes a lot of sense, Jerry. Why should we have to pull all those bolts out? So maybe we convinced them of something yesterday. But I think that's the way we ought to be looking at it. We shouldn't have to pull out the bolts just because there's nil gap or zero gap. If they're not over 55 kips or something on that, or set a threshold on a 7/8 inch bolt, see where you are, and if you aren't over that, if you pull a bolt out and check it, you only got one bolt to reinstall, not a whole mess of them. And the guys are saying, well, we pull the bolts out, put a new DTI on, and retension the bolts. You can't do that. You've got to throw the whole assembly away. You cannot reinstall a galvanized bolt if the DTI is compressed too far and you want to put just a new DTI on it. You've got to throw the bolt away and put a whole new assembly in. Yes?
You run the risk of the ironworkers getting lazy when they install and just crush them all because they know, like you say, by sound and feel, they're not going to try and crush 3 of the 5. They're just going to crush them all. And
No.
all are good as long as they don't go over that threshold.
No, they shouldn't be going over it. They should be watching it and not hitting. They should be having gaps, but
Well, then that's fine if we're
right.
in the basket with them, making sure it's happening. But how many of us are in the basket with them every time they're up?
Well, you're not in the basket every time, but you go after the fact and check. Well, if you get a mess of them,
Right. So
you know, maybe there's a situation where you got to pull a bunch of them out. You know, and that'll wake them up. You know, if you pull out 15 bolts in a connection, but do you have to do it every time, or, you know, on a threshold, how many of them are over that? If you don't find anything over, and if you got some gaps, if you don't have any gaps, you should be having some where you got gaps and some where you don't. And they ought to be having some with gaps. I mean, they shouldn't be pulling everything up fully tension. If they take a whole joint and everything's slam bam tight, no gaps at all, hey, we got an issue here. You're going to take that one apart and redo it. But they've got most of them okay, but there's some that are tight. You got a connection with 60 bolts in and a web splice, and you got 10 of them that are down no gap, but the rest of them have 1 gap or 2 gaps. You're good shape. If the you know, and if you want to pull one out and check it, that's fine. Yes.
I'm just going to ask the question, why can't they reuse the bolts?
Because the spec says thou shalt not reuse galvanized bolts, period.
Okay, I just wondering if there was like a...
It's in the research, you know, we had that slide, and it's in the Research Council spec. Galvanized bolts shall not be reused, period.
What about if it's just a black bolt?
Black bolt cannot be reused if well, you have to get approval of the engineer of record to reuse a black bolt. The state highway engineer, chief highway engineer says, thou shalt not reuse any bolts that have been fully tensioned, then you don't do it. And that's the majority. And the problem is, if you're going to reuse a bolt, you've got to rerun the rotation. You've got to run the thread full length of the bolt So the threads can't be damaged. You got to be able to run the nut all the way to the unthreaded shank, and you're supposed to rerun a row cap test on it. If you can't do it, if you got one bolt you pull out and you got to run a row cap test on it, well, you're going to throw it away. It's more time consuming to reuse bolts.
I know obviously it says that, I was just wondering why.
Well, you're damaging the bolts. That's the problem. You're overstressing the bolts to start with. I mean, you're yielding the bolts, putting them in. And
Okay, but even though the bolt's acceptable, even if it's between 41 kips or up to 60 kips.
yeah,
You don't know if it's a DTI, it's gonna be all crushed. But
right.
You're saying that the bolt is still good all the way up to 60.
Yeah. But that's why, you know, and in turn of the nut method, if it's at 60 kips, you're not going to pull it out. The DTI is good to 50 kips, and you got 55 kips on it. Does that bolt have to come out? If we're turning the nut, we wouldn't take it out. You know, there's some issues there, and you know, the department has to establish a criteria, in my opinion, to work with it. And there are some iffy things there. And the ironworkers, you know, turn of the nut method. You've got a plus or minus 30-degree tolerance on rotation, half a wrench flat. They need to abide by that. They need to pay attention to what they're doing. And sometimes it doesn't happen. Sometimes you have to step on their toes and say, hey, you can't do this. So it's getting that working relationship. And we had on this auditorium that we did, we had TC bolts. We're using A490s, 1.125" bolts. And it was interesting because those bolts have a minimum tension of 80 kips. That 16.5-inch bolt that Ryan showed you, we had to calibrate those. What do you think the tension was when we did turn of the nut on that bolt? 16.5 inches long, minimum tension 80 kips. When we did pre-installation verification, we're up in the range of 115 kips on that bolt. I mean, those are some monster bolts, and you know, there's a lot of work involved there, and they don't want to install or redo any of that if they don't have to, and they paid attention to what they were doing. You guys are a long ways from this project, I'm sure. This is Charleston, South Carolina. We had no bolting issues on this job at all. It's a steel girder, steel exterior girders holding the stays. And then there's floor beams 140 feet long across between the exterior girders. And this is the Cooper River Bridge in Charleston. It was the longest cable stayed in the U.S. for about 4 years, or somebody else tried to get a longer span. Some interesting details here. Foundations. Somebody asked me one time why we don't go to Charleston. They don't drive the foundations. This bridge is 1,546-foot span. Towers are 572 feet to the top above the river. They didn't bear those shafts. The bridge doesn't bear on rock. In Columbia, granite is at the surface, and 120 miles southeast in Charleston, the granite that's at the surface in Columbia is at minus 3,000 feet in Charleston. So needless to say, we don't have foundations in rock. But they're in Cooper Marl, which is a calcareous silt. It's seashells mixed into this silt. And after you get down about 40 feet, 50 feet, you get into skin friction of 1,600 pounds a square foot on these shafts. So we get pretty good skin friction. And these things have 11 drilled shafts, 10 foot in diameter under each tower, 230 feet long. And they're 10 foot diameter. They got 14 number 18 bars in vertically, and number 8 bars on 6-inch centers for hoops. And then there's like 700 yards of concrete in each shaft that was placed continuously. Center of the span's 200 feet over the river. The bridge is 14,000 feet long with about 4 interchanges within the project. And they had everything, they were assigned a contract middle of July of 2001, and 4 years to the date they signed the contract, they opened the bridge to traffic, closed the 2 old bridges. And they had a couple ramps left to finish. They had some approach work left to finish, but the bridge was open to traffic. We don't have any designers in here on major projects, do we? There's no designers in here working here. This bridge was designed, the towers, for example, were designed for 195-mile-an-hour sustained winds for hurricane. At the same time, it's the design, at the same time of that hurricane wind, it was designed for carrying approximately upon 8.0 earthquake, hitting it at the same time. And then it's got an island at the piers, that's an acre at the surface and 5 acres at minus 55 feet that run up and downstream to stop. The islands are designed to stop a 50,000-ton ship moving at 10 knots, either up or downstream. So there were some interesting design criteria in this thing. And the towers were designed to be blast-proof. If somebody parked a truck loaded with explosives next to the tower, they're designed to withstand a certain explosive force. And back in the late 80s, early 90s, we built I-526 north of Charleston, and we didn't have a good state didn't have a good rideability spec. And there's a bridge over there on that route that's 26,000 feet long, and the rideability was so bad on some of the joints that there's 3 land sea container ports in Charleston. And the empty land sea trucks, you know, the container trucks that drive across that interstate, they'd bounce so bad at joints that the wheels on an empty trailer would leave the pavement. And so we had to go through state and federal highway, decided we need to diamond grind that route and smooth it out. We had a very tight rideability spec on this bridge, and it really paid off. But what South Carolina does for rideability is they place the deck, they've got a rideability spec that if they have to grind it, they grind it prior to grooving. And then they groove the deck transversely after the deck is ground, and you get rideability. And they're doing the grinding and the grooving for, at the time when this was built, it was like $3 or $4 a square yard. So it wasn't that big a cost, but they're getting very, very good rides on their bridges these days. But it was an interesting bridge to build. Verification inspection. The reason for and the frequency of verification inspection, lists the steps of the procedures, lists the acceptance criteria. Verification inspection should be performed each day fasteners are really inspected. Each day fasteners are installed, we ought to be doing verification inspection. Be performed for each row cap lot. 3 assemblies are used to establish the post-inspection torque. Average torque from the 3 assemblies is the post-inspection torque. Torque tables are not used. And after yesterday's discussion, Minnesota, in my opinion, has a problem. Because you got bridges, and I've seen this in other states years ago, and I didn't realize, and we maybe have it in other states, but these guys yesterday were telling me, okay, we got this bridge here, and I guess it's here in Minneapolis. They got a whole mess of bridge installed, and they got bolts stuffed in it. There's bolts are sitting in that bridge possibly for months prior to final tensioning. That's true, right? So, you get ready to tension these bolts. How do you know they're going to get tension? Well, if you're using DTIs, that's one thing. Well, what are you doing to the bolts when you try to squeeze the DTIs down? DTIs, that's one case where the DTIs probably benefit you as long as they're under the unturned element. Because they should be under the unturned element so that you know you're pulling that bolt through the structural, you're tensioning the bolt through the structural steel. If it's under the nut, under the turned element, All you know is that you've got the nut tight against, you've compressed the nut against the DTI, and the DTI might crush, but have you put tension on the back end of the bolt through the steel? You don't know unless you got the DTI on the back side. But typically, if those bolts sit there in the steel for a month or 2 or 3, what happens to that, to the lubricant on the bolt? Yeah, what? Goes away. Now that lubricant will wash off. Water evaporates a lot of it, or dissolves it. Heat takes it away. But Minnesota stays pretty cold, so you don't have much sun and summer weather here, right? Yeah, right. I gave the guys the example yesterday. You know, you get out on a bridge and work on it. How many have done bridge construction or worked on the steel in the summertime, and you know, go home, go out to you stop and eat lunch and you lay your tools down. Let's say you lay a square or a pry bar on your steel girder or on the deck of the bridge, and you go eat lunch, and a half hour later you can hardly pick up that tool because it's so hot. You know what the temperature is of that tool if you can pick it up but you don't want to keep hanging on to it? You know how hot that is? If you can't hold on to it for but 10, 15, 30 seconds, it's in the range of 140 degrees. We had a research engineer in South Carolina. He said, you know, they had these, you got these thermometers that you can hold and check pavement, and he said, let's try it. Well, you get that, you get a piece of, like a brown, rusty carpenter square laying out there, and you pick it up. And I ran into that. I worked construction summers with Kramer in Wisconsin, and that's how I paid my way through school. But you'd lay your tools on the deck, go eat lunch, and come back. You couldn't even hardly pick up anything steel laying out there. And I never knew what the temperature was, but it's 140 degrees. Now, what does that do to the bolt, the lubricant in the bolts? And then you add a little bit of moisture to it mornings and evenings, that lubricant's gone. Probably a week or 2 at the most, it's gone. So the bolts sit there in the steel, and if you don't tension those shortly after installation, they ought to be tensioned within a week, maybe 2 weeks at the very most. But after that, you don't have any lubricant on the threads. It's gone. So if you got the DTIs on the front next to the nut, then you really got a problem because you don't have enough lubricant there to pull that bolt. Number one, the nut's going to turn really hard. You're lucky if you can compress the DTI, but are you going to pull it through the steel if there's any binding in the holes? If you haven't got the holes, the connection pinned properly, are the bolts going to move through that hole or through the holes, or are they going to bind in the steel? See, they could look like this bolt. We're going to pass this one around. It could look like that one. That was out of the auditorium in Verona. But we end up with a problem with those bolts sitting there. So your bolts should be tensioned as soon as possible after installation, after sticking them. They shouldn't sit there more than a week or so, at the very most. That's not happening in a lot of cases, and it's a problem. So how do you verify it? Go back out there and pull a sample and see how they perform. Pull one out of the connections and see how they perform for you. Do they work? Do they tension the DTIs properly? Are you over tensioning the bolt to the point where you're overstressing the bolt to get those DTIs crushed even? So we need to get out there and do some checking on that. And it's not a good situation to leave the bridge sit there with them bolts not, just in the snug condition. They need to be tensioned. Again, you walk out to do inspection, verification inspection. Look at the joint. This is just a common sense approach. This is a joint that was checked. These are TC bolts. You don't have to do inspection on those other than are the splines twisted off. They snugged them with an air wrench. And this all started with the Utah DOT back in prior to the Olympics, 8-10 years ago, whenever Salt Lake had the Olympics out there, they rebuilt some of the interstate out there, and they said, hey, the contractor wanted to use TC bolts, and the state was concerned, and I was doing this training and involved in bolting, so I got involved in the process, and we came up with a solution that you use an air wrench or an electric wrench for snugging, because then you don't twist the splines off of the TC bolts until you do final tensioning. And often your snugging might be even close to the final tension, but at least you put the TC wrench on and twist the splines off. So you don't do it, because if you twist the spline off during snugging, it get twisted off during snugging, or did it get twisted off during final tensioning? So we control that. In this case, we got a few that didn't get twisted off because they're too close to get the TC wrench on them. Verification inspection. Install the fastener assembly similar to what's in the structure in a skid tension calibrator. Turn the element nut or bolt that was turned during the job installation. Take it near the minimum tension. Read the torque while passing the minimum required tension to establish your inspection torque. You don't have to do this if you're and see, the advantage of DTIs is you don't have to do all of this. You don't have to do verification inspection with a torque wrench. Torque wrench is out of the picture, and that's why I like DTIs. I don't have a problem with it if you handle them right, because if you aren't out there climbing around with the iron workers, 2 iron workers should be out there running the torque wrench and checking, applying the torque. And the owner's representative would be out there with watching the gauge on the torque wrench and watching the socket turn. Now this wrench I've got here doesn't have an indicator, a beeper, or a light on it. If you get the other wrench, there's another dial wrench similar to this that's got a light or a beep or a little beeper on it. When you get to the required torque, the light flashes or it beeps. Then you know that you've achieved the torque, and then all you're watching is for the socket to turn. But as an owner's rep, you should just be watching for that socket to turn or the wrench to beep, that you got the right torque and socket's not turning. The other thing is, if you establish an inspection torque with a wrench, that same wrench has to be used on the job site. If I establish a torque value of 300 foot-pounds with this 1,000 foot-pound wrench, this dial wrench, I can't take a clicker wrench out there and check my bolts. The same wrench has to be used for establishing the torque as you'd use for inspection. You can't switch wrenches. But DTIs, your verification inspection is with a feeler gauge. So it saves all that climbing around with the equipment, heavy equipment out there, and that's why a lot of states have gone to DTIs. The inspection torques are you establish your torque at your minimum inspection or minimum required tension. Repeat the test for 3 fasteners, average the torque values, and that's your inspection torque. Check 10% of the bolts in the connection, not less than 2 per connection. You find none turn, you accept them. 1 turns, you check all in the connection. Tension all that turn at the contractor's option, retighten all in the connection and re-inspect. That should be the owner's option and not the contractor's option. Best thing to do is monitor the work as it's going on, and at one point or another you should be monitoring some of the stages, every one of the stages that's required at some time or another. At least get a feel for that things are going right. Verification inspection should be within 24 hours of tensioning. After 24 hours of, even 24 hours after stuffing, they say, you should be tensioning, and then yield may be inaccurate and unreliable results may require bolt removal and verify the torque tension. You may have to require or verify torque tension relationship. This isn't quite as critical with DTIs. But the problem is can you get the DTIs tensioned properly later if you don't do it immediately? How long can you go before they don't tension properly? You know, if you're losing all the lube on the bolt. And that's especially true if you put the DTIs under the turned element instead of under the back end of the bolt. I do not like them under the back end of the bolt because you don't know if you're getting tension to the back end of the bolt, the far end of the bolt, the unturned element. What stage of the bolting process should the inspection be performed? For this verification inspection, as soon as the bolts are tensioned. How many assemblies should be checked? It takes 3 to establish your verification torque. Can you use torque tables? No. How many fasteners should be inspected in each connection? Minimum 2, 10%. How soon should it take place? As soon as possible after tensioning. This is another shot of the Cooper River Bridge. This is our this is our yard out by our garden when the a branch broke and we lost about 400 apples. These weren't good, these are deer apples. They're not good eating apples, but the deer don't care. You want to do anchor bolts? Sure. Okay.
All right, anchor bolts and ancillary structures. Who here works with ancillary structures or anchor bolts? You two do? All right, so there's a couple people. We'll talk about common problems that we find with anchor bolts and proper installation procedures. Your slides don't match up with this very well, do they? Correct. So this is a slightly older presentation compared to what we have here. Where's a? And we will. Yep.
Purdue won't give us any books, so we can match their books to our presentation.
Not true. Okay. Huh? Yeah, I added a couple pages. So first we'll do the installation. Pardon? There's a lot going on here. Okay, so we just put the installation up front so that we just flip something. So the slides that are in your book, we talk about maybe in 10 slides from now. So first we'll just talk about the common problems with anchor rods. So we can put it up on here. So the first problem that's pretty prevalent is excessive standoff or too little standoff. The code states it has to be above 0 but under 2 bolt diameters from the bottom of that leveling nut to the concrete. You're not supposed to put that base plate directly onto the concrete or the leveling nuts directly onto the concrete, because the concrete is not going to be perfectly flat no matter how hard they try. So you're not going to be able to properly tension all of the anchor rods during this. This is also going to just increase that moment arm for those anchor rods. So you want to keep them between 0 and 2 bolt diameters. A lock washer is not a structural element. It's not heat treated. I inspected a suspension bridge out in Montana, and we probably found 30 or 40 broken lock washers on connections. They can break very easily. They can corrode a lot easier. And once that thing breaks and gets out of there, that is an improperly tensioned bolt right there. Grout pads. I've heard a lot of horror stories from some of my bosses and from Jerry with grout pads. What contractors would do is they would pack that full of sand and then grout the outer perimeter. That's just about the worst thing you can do for these. That sand is going to hold all that moisture right next to that anchor rod, and you're just going to accelerate that corrosion, and we're going to show some pictures of that corrosion. What they use now, is there going to be a picture? No, that is another picture, but I believe it's in your book where there's a rodent screen.
We got that later.
So it's later on in this. Yeah, sorry about this slide. Most of them should be in there. Those are better than this presentation, so those are more involved, I believe. But what they use is the rodent screen. So for Wisconsin, if there's any electrical, you have to use a rodent screen, but if it's just a signal, just a sign, you don't need anything. You just have to have the standoff, and there's no requirement. And you just strengthen up that base plate, because you're losing that grout, which is supposed to add the strength, but in a lot of cases, they're not installed correctly. So when we find these, we break them out with hammers, because usually they look similar to this. So we remove them so we can remove that moisture from the anchor rods. Here is, I had the privilege of working in South Dakota inspecting about 3,000 light poles. It was a lot of fun. I have a lot of pictures if anybody wants to look at them. Here is one interesting one, is if your base is a little off, you just throw a couple extra structural washers in there and it'll just straighten right back up. There are some very creative solutions that we found. A lot of very creative solutions. So for this, you should use a beveled washer on the bottom if it's incorrectly installed like that, if you're not going to just remove the anchor rods and try again, because this is very, very wrong. So this is what can happen if you have sand or mud. And I found a lot of loose anchor rods and a lot of corrosion. Those are two things that I bet 75% of all poles had one or the other, if not both. If any kind of debris whatsoever got in there, this is obviously extreme, but there'd be some sort of at least minor section loss. So this is an extreme example, but any kind of section loss is going to happen. And what this can also do, if there's any kind of corrosion, if it's a loose anchor rod, you're not going to be able to remove that and retension it as easily. So this is why you don't use grout pads. You want to get that moisture away. Here are a lot of, most of these are from hurricanes, correct?
Some are, this isn't.
This isn't? Okay, I don't believe these are in your book. So this is anchor bolt fatigue. So if you have 4 anchor rods and one isn't tight, so that you can spin it off by hand, which I've seen lots of those. What you're basically doing is you're distributing what that load is supposed to go to those other 3. So they're gaining 33% more load than they're designed for. So you're just increasing that fatigue. This is an example of fatigue, and we have lots of pictures if anybody's interested of different fatigue failures. Anchor bolts not plumb. This is similar to that base that we showed, where it's just off by a little bit. They're not always going to be perfect. For anchor rods, it's suggested that if it's a 1 to 40, you're going to use a beveled washer, because that nut is supposed to sit on there and it's going to be a distributed load. With this, you're making it a point load. It's just going to increase the chance that it gets loose, and a lot of different issues can come from that. So beveled washers are suggested. Loose top nuts. I've seen a lot of loose top nuts because of loose. So you have the jam nuts or the top nuts, and then the loose anchor nuts. Those will be loose. People believe that a top nut will keep that tight regardless. A top nut will keep a properly tensioned nut tight, but if this isn't properly tensioned, that top nut is also. They're all going to come right up like that. So there is a procedure. I believe we touch on it in here a little bit, but if not, you can find it in the RCSE code. So you don't tension that, obviously, with the torque that you do the anchor nut, but there is a specific tension you're supposed to take it to. And this is with the loose leveling nut. You are supposed to snug that, so about 20 to 30% of the tension. That's what you're supposed to put on, though. You don't just set them on there and then only worry about the top. We also see a lot of loose leveling nuts as well. So the procedure is, and I believe that now we've flipped to the front, you place the leveling nuts. You want to place the base plate. You don't want any attachments on that pole. You don't want to put any kind of eccentric loading. You just want just that axial load, or else you're not going to properly tension everything. You put on any sort of mast arms or signs, or if it's a traffic light, you put that on after you have everything properly tensioned. So you bottom of the base plate, not more than 2 bolt diameters. So you want to make sure you have the proper standoff there. Then you snug the top, you snug the leveling, and then you properly tension the top nut. It's very important for a lot of these anchor rods. I know we're used to seeing 1.25 inches to 1.5 inches, if not even larger. And that can be very difficult to achieve. So we use slugger wrenches or hydraulic wrenches. And I believe there's a video coming up here. Well, there is a video coming up here that shows what we use. And you guys don't use anything above 7/8 in your top connections, right? Is that true? You guys only use 1.5 inches on the bottom? Because we use 1.5 inches in Wisconsin. They allow 1.5 inch bolts in the top. And that gets a lot of fun, too, with a lot of loose connections. So has anybody seen a hydraulic wrench been used for anchor rods or tightening these? This is what we suggest, and a lot of the contractors around Madison are starting to use this. So what you do is you have to put some sort of piece of steel so that the hydraulic wrench can rest against, and then you just do the proper turn of the nut. And with these bigger bolts, the turn of the nut's going to be significantly less than the 7/8 or the 3/4. So it's a lot faster and easier, but you can also use a slugger wrench as well, which is just, then you just use a hammer to tighten them. Because using a bar like that, you'd need a very long bar, because what were we tensioning these to, 500-600 foot-pounds? Some of those anchor rods can get up 1,000-1,500. That's quite a long bar, and usually it's an unfinished project, so you're going to be standing in mud and things like that. So
Can you adjust your nuts according to foot-pounds?
for what?
Can you adjust the nuts according to foot-pounds rather than marking them and turning them? Like you say you tighten them to 1,000 or 1,500 pounds, and that would be good, or would that?
No, the procedure is in your book, and that's
This
developed
one.
by Rob, oh shoot, what's his name? He was doing research at the University of Minnesota, and he's the one that developed, Bob Dexter. And he put together the procedure, but it requires a torque plus turn of the nut method. It's a combination of them. For those of you that haven't seen a slugger wrench or don't know what we're talking about, the head of this wrench in here is a slugger wrench. The handle's about down to here normally. And I cut the hand, there's a square end on it that you hit with a 10-pound sledgehammer. I cut the square end off so I could stick it in a pipe and weld it in the pipe and use it as my breaker bar. But it's got a head on it like this. Both of our wrenches this is one for a smaller diameter. The head on this one, the square end started here and went down to about my hand. This is a smaller diameter slugger wrench. Those are ones. And the way you use them, you put it on the bolt, and you have your buddy hold his foot on the wrench. You hit the wrench handle with the 10-pound sledgehammer while your buddy's standing on the head of the wrench. That way you don't hit your own foot.
And as you can see, the turns required for turn of the nut is significantly less than the 2/3 or half that we were seeing with the 3/4 and the 7/8 bolts. If it's greater than 1.5 inches, all you need is 1/12 of a turn, so it's not as much. Did we miss anything? This is a table that just shows the tension-torque relationship. So for a 36 or 55, for like 1.5 inches, which is what I'm typically used to seeing, you gotta get it 615 to 945 foot-pounds in order to properly tension that. So much like for other bolts, you want to verify the minimum torque again 24 to 48 hours after installation. And you also want to check the leveling nuts. Now so these are all pictures from hurricanes that show using multiple lesser grades anchor rods is better than using just a few of the higher strength for fatigue reasons. These ones, how many did they lose?
South Carolina during Hurricane Hugo in '89 had 13 structures that had damaged concrete pedestals. And you can see the offset in the upper picture. It's almost offset 2 inches. It spalled the concrete around the base. Rotated the sign, but they had, out of the 13 damaged bases, they had 3 or 4 that they replaced down toward the foundation. The rest of them, they were able to repair them at the base, but they had 135-mile-an-hour sustained winds in that hurricane. These signs, these 2 sign pictures here were 45-foot cantilevers out at the airport where the wind was sustained at 135 miles an hour. They never lost the first cantilever. And these were all grade 36 bolts, 8 to 10 bolts per pedestal. None of them fell. So I think that says a lot for redundancy.
Yep, redundancy and
More
proper.
bolts, the better.
So this is just a monotube. Here's the part, I believe these are all taken out of your book. Here is some more from fatigue. This can show a fatigue if you have a couple loose nuts. One loosens, another one loosens, you're just adding more load to the rest of them. And as you get more fatigue cycles, as we discussed earlier, this can occur. And we've seen, how long was the world's largest light pole up? Flag up 3 days or a weekend or something like that?
4 days.
Just because they didn't properly tension the nuts. They had a 400-foot flagpole, the largest in the world or the country?
In the country.
In Sheboygan.
Wisconsin, for acuity.
Yep, and they're on the 3rd one now or 4th one?
They built 3rd or 4th one now.
Yeah.
It's 410 feet.
Yep, but not properly tensioning, it fell down within 3 days. So proper tensioning is pretty important. Here is what a J-hook can do. Down at Purdue University, Rob Connor did a test where he took a J-hook, which is, do we have, no, there's no pictures in here either. So instead of coming down and then putting a nut, like what we suggest you use like this, it would come down and it would just hook. So he attached something to the top and he pulled on it, seeing how much it would take for that anchor rod to yield. It never did. It failed like this and they pulled straight up. So now we have to flag these when we inspect them. We perform UT, and whenever we believe there's a J-hook, we have to let WSDOT know what's going on there, because they don't use these anymore. Now you use this thing where you have just lock nuts here, and then usually they have one here with a template, so it's a lot more difficult to pull out, and you're not going to have that as often. For this is what you want. You want to have just a standard structural a whole assembly up there. This is an E-prime fatigue category, and the reasoning is that bolt right there is going to be about 120 to 150 KSI, and that steel that it's going into is going to be 50 KSI. So you're not going to get enough strength there, so it's a lot easier for them to become loose or pull out. So Wisconsin, at least everything on the state highways, is now going to a full assembly where the bolt goes entirely through it. They've done a lot of research with this and found that that does not work very well at all. Oh, here's a picture of so here's what a rodent screen or varmint screen, whatever they're called around here. Rodent screen is what we call them. That's what they will look like. Keeps things from eating the wires. Here is, as Jerry like to say, they built the road too high, so they just put one more base plate in there. Something like this, there's no way anybody could tension every one of those bolts. It'd be a pretty big accomplishment. The base plate template was incorrect, off by 45 degrees, so this was their solution to put the sign right. You could probably just take off the base plate and re-weld it. Would probably be easier. Something like this is going to become loose. Has a lot of moving parts. Here's a loose anchor rod nut. And I have seen them all the way up, almost falling off the top of them before, just especially with the light poles where those things really move. Those things will shoot right up if they're not properly tensioned. Here's what it can look like if you try to tension directly to the concrete. You're not going to get proper tension. It's just going to work its way loose because that concrete is not flat. Loose leveling nuts. And this is the bottom of a retrofit, which is this. High mass tower base, we talked with Iowa DOT, and they've started using this on some things down in Des Moines, and they've actually had very good results with it because you're tensioning more of that length of that anchor rod. So they've actually had very good fatigue resistance with this detail. So we don't know a whole lot about it, but this picture was taken a while back, but they've started doing it again. I don't think it's just on high mass, maybe on some signals as well. So they've had good luck. Here, I believe this is in South Dakota. That's what the guys out in South Dakota told us. This is some research from Purdue University on strengthening up high mass light poles, which obviously go through a lot of fatigue.
They put all these little bolts in and there's still a guy inside that bolt.
Yeah, they leave them in there. All right, if anchor bolts are out of plumb, what type of washer shall be used? That's a beveled, and if it's a 1 to 40 slope, that's what they suggest for ancillary structures. When would fatigue be an issue? If anything's loose, you want to make sure anything with leveling or anchor rod nuts are tight. What type of washer should never be used? A lock washer should never be used in a tension connection, ever. What type of defects would accelerate corrosion of an anchor bolt? Water, yeah, anything that's going to allow water to sit next to it. So soil, sand, anything. That's why we don't use grout pads. That's a deer. Does anybody have any questions? You want to